हेलो फ्रेंड्स, मैं डॉक्टर सरबजीत राला। आज आप मेरे साथ पढ़ेंगे न्यू टॉपिक व्हाट इज़ द हाइड्राइड शिफ्ट। सो हाइड्राइड शिफ्ट जो है उसको पढ़ने से पहले मैं बेटा उसकी एग्जांपल बताऊंगा कि व्हाट इज़ द एग्जांपल एंड व्हाट इज़ द मैकेनिज्म ऑफ दिस रिएक्शन। सो लेट्स स्टार्ट। इफ़ वी हैव हियर CH3 CH CH3 and CH2, and here is OH, and if we add here HCl, so what will happen here? We will get the two kind of the product. One of them is the CH3, and here is CH3 and this Cl, and here is the CH3, and with the loss of water. So this product will be formed in the major, that will be the major, that is a 90%. And second possibility is that here CH3 CH3 CH and CH2 and Cl. This possibility which is the minor, that is the 10%. Suppose it is the 10%. So now we have to study the mechanism of this reaction, that why it is a major and why this is minor. That can be explained by the 1,2 hydride shift. So from this we will study the complete mechanism of this reaction. So let's start the mechanism of this reaction. What is a hydride shift here? So now see here that on this reaction arrow, which is on the arrow, that is called here reagent. This is the reactant, these are the product. So the reagents are the reactive, and we will start the mechanism from the HCl. That is, HCl is an reagent that will dissociate into the H positive and the Cl negative ion. Now what happened here, we will see here that in the reactant, this is the CH3, here is the CH, here is the CH3, here is the CH2, and here is OH. You know that this is the alcohol here. So this is what here 1 2. If we talk about the name of this reactant, this is the 1 2, it is the 2 methyl propanol. This is the 2 methyl propanol. So this is the 2 methyl propanol which we had taken as a reactant. As we know that this alcohol has OH, so this 2 methyl propanol, so this oxygen of this alcohol has a lone pair. This oxygen will donate its lone pair to this proton, and therefore now what we will get here, we will get CH3 CH, and here is the CH3 and CH2, and here is OH. As we know that this oxygen has donated its lone pair to this proton, so therefore this oxygen will carry which charge? Positive. And now we know that here this oxygen is being an electronegative element, do not require the positive, and if we compare the electronegativity of this oxygen and carbon, oxygen is more electronegative than that of this carbon. Therefore it withdraw the electron density toward itself. So if it withdraw the electron density toward itself, so now what we will get here, CH3, here is CH, here is the CH3, and here is the CH2. Now this is here. Now from this reactant we have the two possibility. So let's start. What are the two possibility here? You know that this carbon carry positive charge is attached to how many carbon atom? This is attached to only this carbon atom. So therefore the carbon carry positive attached to this carbon is called here primary carbocation. This is called here primary carbocation. Now two possibilities are here. If I talk about the two different possibility, so let's start. What are the two possibilities here? So if this is, you know that we have added here the HCl and the Cl carry negative charge. The one of the possibility is that the Cl negative can attack here easily. So if the Cl will attack easily here, then what we will get here, CH3, here is the CH, and this is the CH3, and we will get CH2Cl. So this is here 1 2, this is the 2 methyl chloropropane that we will get here. So Second possibility of this is here, this carbon, this product form is the minor. So we are talking, this is here minor. So what will be the major? So now what we will be the major product? See here that this carbon with which this hydrogen atom has been attached. So if we talk about that, okay, this hydrogen is here. So now this carbon has positive charge. So if now this carbon with its bonding pair electron will shift here, and this is called is hydride shift. So therefore this is called here hydride shift, when this hydrogen with its bonding pair electron will attack on this carbon atom. So therefore now what, this CH2 become here CH3, and therefore this this bond has been broken from this carbon, and therefore this carbon will carry with charge positive. Now see here that now what we will get here, CH3, and here is the CH3, and here is the CH3, and this carbon carry with charge positive. You know that very well. Okay, this carbon carry positive charge attached to how many carbon here? 1, 2, 3. So this is called here tertiary carbocation. So this is third degree carbocation, which is called here tertiary carbocation. As we know that in the previous video we had told that you that okay, out of these carbocation, tertiary carbocation is more stable than that of the secondary and the primary. So now in this topic here is the primary carbocation, and this is the tertiary. So therefore in order to attain the stability, this hydride shift is necessary here. So if this is the primary carbocation, so this is the minor product will form. So if this hydride shift will be here, and therefore we will get tertiary carbocation, and then after there will be the attack of the Cl. Therefore ये जो Cl है वो HCl से आएगा. So therefore this will attack now here. So what we will get, CH3, and here is the CH3, here is the CH3 and Cl. So this is called here tertiary butyl chloride. It is called here tertiary butyl chloride. So this is called here hydride shift. So I have explained with the example and with the mechanism that what is hydride shift. So this is hydride shift. So after that that we will do the one more example of this hydride shift. Friends, जो next example है hydride shift की वो ये है, we have taken this molecule here, this is here 1 2 3 4, it is called here 3 methyl 1 2 3 4, it is the 4 carbon, that is butane and 2 ol. So this is 3 methyl butane 2 ol. That is 1 2 3 and 4. 3 जो position है उसके ऊपर methyl है. That's why we write here the 3 methyl, and here is butane 4 carbon butane, and second position के ऊपर alcohol लगा, that's why 2 ol. So if we add here the HCl here, so we will again two kind of the different product will form. So now see here what are that, CH3CH and CH3, and here is CH and CH3, and it will be the one of them is will be the Cl. This is here minor, and what will the major product, CH3, and this is the CH3, this is the Cl, and CH2 and CH3. This will be the major product here. So this is also due to the hydride shift. Now we have to explain this mechanism of this reaction, why this is major and why this is minor. So in order to explain this we have to write the mechanism of this reaction. Let's start. So if we have here, you know very well that here is this is the reactant, this is the products are there, and this is the reagents. You know the reagents are the reactive than that of the reactant. So we start with the HCl, and therefore HCl will dissociate into H positive and the Cl negative. This is the first step of this mechanism. Now what will happen here, we have here CH3, here is the CH, this is the CH3, here is the CH, here is OH, and here is CH3. What will happen here, we will add the proton here. As we know that this alcohol This is OH has a lone pair. So therefore what will happen now here, this oxygen will donate its lone pair to this proton. Now in the next step, see the what will be here, CH, here is the CH3, and here is the CH, and here is the CH3, and this O, यहाँ पे H, and this H. Now we know, you know that this oxygen has donated its lone pair, and this therefore this oxygen will carry with charge positive. So if this oxygen will carry positive charge, and now what will happen out of these carbon and oxygen, which is more electronegative, this oxygen is more electronegative, and being an electronegative element, this do not require the positive. That's why this withdraw the electron density toward itself, and therefore this carbon will carry with charge positive. So see here that now what we will get, CH3, here is CH, this is the CH3, and here is the CH, and this carbon carry positive, and this is the CH3. Now from there, from this position, we have the two possibility that again I will write here the two possibility for this direction. So what will happen now, the Cl negative will add, Cl negative will be added here. This carbon carry positive charge. Now carry how many, this carbon carry positive charge attached to how many carbon atom? 2. This carbon attached to this carbon is attached to this carbon. That's why this is called here secondary carbocation. It is called secondary carbocation. So still it is the secondary. So therefore this possibility is there. Okay, this Cl can attack now here. Now what we will get here, CH3 and CH, this is the CH3 and CH and Cl and CH3. This is the minor. Now what will happen now in the hydride shift, which is important to discuss here. If we talk about that the Cl will attack here. Now what is here possibility? I have added here the Cl negative, I have written here, but see the next step, what will be the hydride shift. If we talk about that कि इस step को मैं दोबारा से यहाँ पे लिख लेता हूँ in order to explain that, CH3, here is CH3, and here is H, and here is H positive, and here is the CH3. Now see here that this carbon carry positive charge is the attached to 2 carbon atom. This is secondary carbocation. Now what will happen? So there will be the hydride shift from this to this carbon. As we know that this is the 1-2 hydride shift, so we will write here it is 1-2 hydride shift. So this is the hydride shift here. So now what will happen? If this hydrogen with its bonding pair electron will go on this carbon atom, and therefore it will become CH2, and this bond has been broken from this carbon atom, and therefore this carbon will carry with charge positive. So see here that this is the CH3, and here is the CH3, and this is the CH2, and this is the CH3, and now this carbon carry with charge positive. The carbon carry positive charge attached to how many carbon atom? 3. So see here that this carbon has been attached to the 3 carbon, 1, 2, 3, and now the Cl negative will can be attacked on this. So therefore as we know that tertiary carbocation is more stable than that of the secondary carbocation. यहाँ पे secondary carbocation बना था, यहाँ पे tertiary carbocation बन रहा है. So tertiary carbocation is more stable than that of the secondary, and therefore the Cl now will attack here. The what we will get, CH3, and here is the CH3, and here is the CH2 and CH3, and the Cl now will attach here. So this is major, and this is the major product, and this is the minor that we will get. So this can be explained by the hydride shift. So thank you friends. यहाँ पे देखें इसका जो पहले मैंने रिएक्शन लिखी थी. So this is product formation with the hydride shift. So thank you friends. अगर आपको मेरी वीडियो पसंद आए प्लीज़ इसे लाइक करें, सब्सक्राइब करें मेरे चैनल को, एंड कमेंट्स करके बताएं. Thank you friends.